It's the MIT Integration B 2023 Finals problem number 2. So we've got the integral from 0 to pi of a function of sines squared dx. This function of sines, sine of 2x times sine of 3x times sine of 5x times sine of 30x, all divided by sine of x times sine of 6x times sine of 10x times sine of 15x. We're going to use an identity here to simplify this thing. So we're going to use the fact that the sine of alpha x is equal to e to the alpha ix minus e to the negative alpha ix all over 2I, the exponential form of sine. And so we can go through here and we can write out the sine of 2x over x in terms of this exponential notation. And when we do this, we can also factor some things out and simplify things even further. So the sine of 2x over sine of x is equal to e to the negative ix multiplied by e to the 4ix minus 1 over e to the 2ix minus 1. I'm going to go through each part of the function f of x and do this. So for sine of 3x over sine of 6x, again we're going to write it out in exponential form. You'll see that the two i's in the denominator of this sine exponential form will cancel out. That's why you don't see them here in the expressions. And simplifying some things, we get e to the 3ix times e to the 6ix minus 1 over e to the 12ix minus 1. So you'll see a lot of these have the same general form. This will be cleaned up in a moment as well. So now we have the sine of 5x over the sine of 10x. That'll give us e to the 5ix, e multiplied by e to the 10ix minus 1 over e to the 20ix minus 1. And finally, for sine of 30x over sine of 15x, we do the same. And in a moment, we're going to multiply all of these things together. But before we do so, let's let lambda equal e to the 2ix, and then we can get the square root of lambda to be e to the ix, and so forth, and this will simplify some things in terms of our expression. We can write f of x now as 1 over lambda to the 4th, multiplied by lambda squared minus 1, lambda cubed minus 1, lambda to the 5th minus 1, lambda to the 30th minus 1, over lambda minus 1, lambda to the 6th minus 1, lambda to the 10th minus 1, and lambda to the 15th minus 1. That's a mouthful. So this entire expression reminds us of something called cyclotomic polynomials. So by definition, a cyclotomic polynomial, here defined by capital phi of n, is a product of factors where we use something called the primitive roots of unity. Now, without going into too much detail, we're going to use a relation that comes from this, and that is a way to generate factors. So we can say that x to the nth power minus 1 is going to be equal to the product of these cyclotomic polynomials when d is a divisor of n. And not to get into too much detail, you'll see how this works in a moment. So x to the prime power p minus 1 can be written as phi of 1 multiplied by phi of p. The large pi symbol means a product. So the first cyclotomic polynomial works out to be x minus 1. And factoring x squared minus 1, we can see that that would be the same thing as doing x to the raised to the power prime p of 2, so we can get a factorization that way. So in general, x to the p power minus 1 over x minus 1 is what we call the cyclotomic polynomial p of x. And it's basically a power series here in x, all the way up to the power of p minus 1. And for powers that are multiples of prime, and that is multiples of 2 of primes, we can write out the factorization as well as an alternating series. Perhaps in another video I'll do a more full explanation on cyclotomic polynomials. But it'll all come together now here. So we have a function here of lambda, and the inner function there we'll call g of lambda. Now it's a pretty complicated function, so we're going to try and simplify it down using these cyclotomic polynomials. So the first sort of ratio there, lambda squared minus 1 over lambda minus 1, is really just lambda plus 1, which is our second cyclotomic polynomial. And for lambda 3 cubed minus 1 over lambda to the 6 minus 1, we get 1 over the product of the cyclotomic polynomials 6 and 2. Similarly, we calculate for lambda to the 5th minus 1 over lambda to the 10th minus 1, and that's going to be 1 over phi 10 and phi 2. Now, for powers that are not products of a single prime here, or maybe it's not a double prime, all right, when we write out the factors, it's a product of all the cyclotomic polynomials that have divisors of the power there. So again, not going too much into it, a lot of stuff cancels out here, and we get that lambda to the 30th power minus 1 over lambda to the 15th minus 1 is equal to a product of these particular cyclotomic polynomials. And now it's just a matter of multiplying these all out to simplify what we're going to see. A lot of things cancel here. So when we multiply all of that out, we just are left with the cyclotomic polynomial 30. And we can calculate what that is in terms of lambda, which is really just some sort of alternating series here. So we can write this as a power series in shorter notation. The whole polynomial inside there, lambda to the 8th and so on, is a power series, and all the coefficients of that power series are either 1 or negative 1. That's going to become important in a little moment. So the function f of lambda is 1 over lambda to the 4th times this power series. And this is where something called Parseval's relation comes in. Parseval's relation is going to say that the integral from 0 to pi of f squared is going to be equal to doing the same thing instead of squaring it, using the function times its complex conjugate. So this is going to be an equivalence relation here that we're going to use. 1 over lambda to the 4th can be written back in exponential form, since lambda is e to the 2ix. And the function that we have now, f of lambda, is f of e to the 2ix is equal to e to the negative 8ix times g of our lambda, or g of e to the 2ix. And then now all I'm going to do here is find its complex conjugate so that we can put that into the integral formula. The complex conjugate of e to the negative 8ix is e to the positive 8ix, and then we just have to take the conjugate of the function g of x, or g of e to the 2ix. So now, multiplying those two things together, the function and its conjugate, to get f squared, we're going to see that the exponential form is going to serve us nicely here, and a couple of things will cancel out, and we'll replace some things with the power series notation. So the power series notation for the original g of x here is substituted in, and we write in a power series here for the we'll also write a power series here for the conjugate for g of x as a conjugate of a power series. Alright, so we'll use the variable j here, and we'll note that we're taking the conjugate here with the bar notation. Alright, so once we want to write out f squared, which is the integrand squared, we're going to write it out in exponential notation in this form, and we're going to have the product of two infinite series, but those infinite series are basically of the same type, even though we're using two dummy variables. So we're going to be able to combine those infinite series nicely. Alright, so now the e to the negative 8ix and e to the 8ix will cancel to 1, or multiply to 1. And then we're left with just the product of the coefficients ak and aj prime, which are going to help us rewrite that as the absolute value squared of the coefficients. That's essentially the same thing. So we can now combine some like terms and take the integral to finally evaluate the integral from 0 to pi. And when we do that, we notice that when we take the sum of the coefficients squared, all the coefficients were 1, if you remember before, and there were 7 terms in our g of lambda. Let me just write it out here. G of lambda was lambda to the 8th plus lambda to the 7th, and so on. That was actually, if I also remind you, that there's a cyclotomic polynomial of 30. So since there are 7 terms here, 7 coefficients, all equal to 1, when you sum them up, there's 7. So that's going to be a constant we can pull outside of the integral now. And so the integral is just from 0 to pi of e to the 2ix k minus j summed over would just now simplify to 7. So basically the integrand will go to 1, and then you'll integrate from 0 to pi of x, and that's just going to give you pi. So the integral is equal to 7 pi. I hope you enjoyed this video. Please like, subscribe, and hit that notification bell for more videos. Stay tuned.